You wake before sunrise and hear rain striking the windows. Not a gentle shower, Florida rain. Heavy drops hammer the roof of the astronaut crew quarters while water runs in sheets across the glass. Your bags are packed, your suit has been checked, your family has already said goodbye. A rocket taller than a building is waiting a few miles away, but the sky is completely gray. A weather officer watches clouds drift over the launch pad. Instruments measure electric fields in the air. Radar tracks storms forming beyond the coastline. Farther out over the Atlantic, recovery teams study the waves. Then the message arrives. The weather is no-go. Launch delayed. Again. You have trained for years to leave Earth. Now the only thing standing between you and space appears to be rain. Back in your normal life, rain is barely an obstacle. You open an app. You see a cloud icon. You take an umbrella. Your commute becomes slower. Your shoes get wet. Maybe your delivery arrives 10 minutes late. That is the entire crisis. But when astronauts are preparing to sit on top of hundreds of thousands of kilograms of fuel, weather stops being an inconvenience. A cloud is no longer just a cloud. Wind is no longer just wind. And rain is rarely just rain. So, what do astronauts actually do when it rains all week on Earth before their launch? The first thing to understand is that rockets are not automatically grounded because water is falling from the sky. Rain alone may be manageable. The real danger is everything that can come with it. Electrical charge, lightning, strong winds, thick clouds, ice, hail, turbulence, poor visibility, dangerous ocean conditions, and weather along the rocket's escape route if something goes wrong during ascent. For crewed Falcon 9 and Dragon missions, launch rules examine whether the rocket would pass too close to disturbed clouds extending into freezing temperatures and producing moderate or heavy precipitation. They also restrict flight through certain thick cloud layers and suspend launches when electrical field instruments near the pad detect conditions that could support lightning. The sky can look quiet to you while being electrically dangerous to a rocket. That is because a launch vehicle may help create the very lightning strike that threatens it. A long rocket climbing through an electrically charged cloud can provide a conductive path through the atmosphere. The cloud does not necessarily need to be producing obvious natural lightning at that moment. The vehicle itself can trigger a discharge. NASA learned this lesson dramatically on November 14, 1969. Apollo 12 lifted off from Kennedy Space Center beneath a dark, rainy sky. About 36 seconds after launch, while the spacecraft was roughly 6,600 feet above Earth, lightning struck the vehicle. A second electrical event followed at 52 seconds. Inside the command module, warning lights appeared across the control panels. 3 fuel cells went offline. Telemetry reaching mission control became almost unreadable. For a moment, the second mission intended to land humans on the moon looked as though it might end before reaching orbit. Then, flight controller John Aaron recognized the strange pattern from an earlier test. His recommendation was short. Try SCE to AUX. The signal conditioning electronic system was switched to its auxiliary setting. Useful data returned. The crew restored the spacecraft's systems, reached orbit, and eventually continued to the moon. Apollo 12 survived, but the incident helped drive stricter rules designed to keep rockets away from clouds capable of producing triggered lightning. And this is where the situation becomes more complicated. Astronauts are not waiting for good weather in one tiny circle above the launch pad. They need acceptable conditions across an entire chain of possible emergencies. During a crewed launch, the spacecraft carries an abort system. If the rocket fails, the capsule may have to pull away and descend somewhere along the flight path. That means teams must consider weather near the pad, over surrounding recovery areas, and at potential abort locations farther downrange. A bright patch of sky above Kennedy Space Center does not help if thunderstorms, high waves, or dangerous winds are waiting where the capsule might have to land. NASA launch updates routinely distinguish between conditions at the pad and conditions along the spacecraft's flight path. Both must be acceptable before the crew can launch. So while rain falls outside, the astronauts wait inside a system that remains extremely active. Meteorologists update forecasts. Mission managers review the next launch opportunity. Engineers inspect the rocket and spacecraft. Recovery teams evaluate the ocean. Flight controllers examine how a delay affects the mission timeline. And the astronauts remain in quarantine. For recent NASA missions to the International Space Station, crews have commonly begun a health stabilization period roughly 2 weeks before launch. Their contact with other people is limited so that a cold, influenza infection, or another communicable illness does not enter the spacecraft or travel with them to the astronauts already living aboard the station. This creates a strange situation. The launch date moves, but the astronaut's life does not immediately return to normal. You cannot simply leave quarantine, visit a crowded restaurant, meet dozens of friends, and come back when the clouds disappear. The mission may be delayed by only 1 day. The next acceptable window may be tomorrow morning. So, the crew stays protected, isolated, and ready. At Kennedy Space Center, astronauts live in dedicated crew quarters inside the Neil A. Armstrong Operations and Checkout Building. It is not a prison cell. There are bedrooms, meeting areas, dining facilities, and spaces where the crew can review the mission. But every person allowed near them becomes part of the health protection system. The rain continues. The outside world keeps moving. The crew's universe becomes smaller. They study procedures. They speak with flight surgeons. They receive weather and mission briefings. They exercise. They review emergency checklists. They may use simulators to rehearse spacecraft operations and remain sharp while engineers work through delays. During the prolonged preparations for Boeing's crewed Starliner test flight in 2024, NASA astronauts Butch Wilmore and Suni Williams remained in pre-flight quarantine and continued working with Starliner simulators while mission teams addressed launch issues. Sometimes the weather forecast is clear enough that the delay happens before the crew suits up. That is the easier version. The astronauts stay in quarters. The launch team selects another opportunity. The carefully choreographed launch day sequence never begins. But weather can change quickly. A crew may wake up, eat its traditional pre-flight meal, receive a briefing, put on pressure suits, complete leak checks, and travel to the pad. The astronauts climb into the capsule. Technicians secure them into their seats. The hatch closes. The countdown moves forward. Then the clouds move. The electric field rises. A recovery zone becomes unacceptable, and the launch director calls a scrub. Now the entire process runs backward. Propellant operations must be made safe. The launch team secures the vehicle. Ground crews reopen the spacecraft. The astronauts unstrap, climb out, and return to crew quarters. NASA practices this scenario because improvising it on launch day would be unacceptable. In a 2025 Artemis Theseou training exercise, the crew traveled the 9-mile route toward Launch Complex 39B before teams declared a simulated scrub. The astronauts then returned to crew quarters, rehearsing what would happen if an actual launch were postponed. Real crews have completed the same reversal. When NASA and SpaceX scrubbed a Crew 10 launch attempt in March 2025 because of a ground system problem, Anne McClain, Nicole Ayers, Takuya Onishi, and Kirill Peskov exited Dragon and returned from the pad to astronaut crew quarters. The cause was mechanical, not weather. But for the people inside the capsule, the emotional sequence was nearly identical. Prepare, suit up, strap in, stop, unstrap, return, begin again. And a launch delay does not always mean trying again the next morning. Orbital mechanics control the schedule. A spacecraft traveling to the International Space Station must launch when the station's orbital path and the launch site align correctly. Miss that opportunity and the mission may have to wait for another precisely calculated window. Weather may also be acceptable at the pad, but unacceptable downrange. In February 2023, NASA and SpaceX passed over a Crew 6 launch opportunity because of forecast conditions and moved toward the next available attempt. In July 2025, Crew 11 was postponed because of weather near Kennedy, while teams continued evaluating both pad conditions and Dragon's flight path for the following attempt. One cloudy day can shift transportation, staffing, recovery vessels, tracking support, station operations, and the schedules of hundreds of people. A week of poor weather can turn a fixed date into a moving target, and yet the astronaut is expected to remain ready as though launch could still happen tomorrow. But here, the story takes a turn most people do not expect. The hardest part may not be the rain, it may be the collapse of certainty. Astronauts spend years preparing for motion. Engines ignite. The vehicle accelerates, stages separate, orbit begins. Training is built around actions, call-outs, and decisions. A weather delay demands something completely different: stillness. You must hold the same level of concentration without knowing when you will be allowed to use it. You cannot become too excited because the launch may be scrubbed again. You cannot relax completely because the next attempt may already be approaching. You live between departure and return without having done either. That may be why waiting is not treated as empty time. The crew reviews, the crew rehearses, the crew exercises, the crew protects its health. The launch team collects more data. Readiness is maintained through repetition. Not because astronauts have forgotten what to do, but because uncertainty is itself part of the mission. Spaceflight is often described as humanity defeating nature. That is not quite right. A rocket does not defeat gravity. It uses carefully calculated energy to move through it. A launch team does not defeat weather. It studies the atmosphere, identifies the boundaries, and waits until the risk becomes acceptable. The achievement is not domination, but cooperation with forces too large to control. That is also why a scrub is not automatically a failure. To a spectator, the rocket remained on the ground. Nothing happened. To the launch team, the safety system worked exactly as intended. Measurements were taken. A hazardous condition was identified. The countdown stopped. The crew returned safely. The absence of a launch may be evidence of good judgment. Now return to the room at Kennedy Space Center. Rain still runs across the window. The astronaut who expected to be in orbit is still on Earth, but the crew is not simply watching television and hoping for sunshine. They remain quarantined. They attend briefings. They review procedures. They train in simulators. They exercise, rest, and prepare for another attempt. Outside, weather teams track lightning, clouds, winds, and electrical fields. Farther along the flight path, other teams evaluate seas and recovery zones. Engineers protect the vehicle. Mission managers calculate what the delay changes, and when every part of that chain finally agrees, the crew suits up again. The door closes, the vehicle rolls toward the pad. The astronauts climb back inside. Because launching into space is not about leaving Earth at the first possible moment. It is about being prepared to leave at the first safe one. Sometimes the most important thing an astronaut does before going to space is wait.